3, okay.
Yeah.
So 3 to the power of m plus 4, Mr. Like we split them, Mr.
You want us to split it?
Yeah, yeah.
Okay, so if we split, this is going to be written as 3 to the power of m
multiplied by 3 to the power of 4.
multiplied by 3 to the power of 4. Okay.
Minus 6.
6.
If it's a split 3 to the power of m plus 1.
So we splitted this one first. Now you want us to split this one. Okay. So this one we're going to write it as what?
3 to the power of m.
3 to the power of m
multiplied by 3 to the power of 1.
multiplied by 3 to the power of 1. Okay, this is all over.
Yeah, Mr. So like I really will simple 3 to the power of m split alone.
So you want me to write it as 3 to the power of m, yeah,
multiplied by 3 to the power of 2.
3 to the power of 2.
Yeah, Mr. So multiplied by 7.
Multiplied by 7. Okay, sure.
So Mr. Garra, like only like something common between them.
Yeah.
Which is 3 to the power of m. So we inject the variable.
Okay, so you have 3 to the power of m here. You also have 3 to the power of m here. And then they are separated by a minus. So this is term number 1. And then this is term number 2, because there's a multiplication in between 1, 2, 3 again. Okay. So you want me to take something common between the minus again. Okay, if I take out something common here, I'm going to have 3 to the power of m. And then what am I going to remain with then?
3 to the power of 4.
So I'm going to have 3 to the power of 4, yeah?
Minus 6 multiplied by 3.
Multiplied by 3.
Yeah.
And then
to
the power of m.
To the power of 1.
To the power of 1.
Yeah.
Okay. Okay, so it's 3 to the power of 1. So I don't have to write the 1. Yeah. Okay. So it's bracket. All over, yeah.
3 to the power of m.
3 to the power of m.
Multiplied by 3 to the power of 2.
Multiplied by 3 to the power of 2.
Yeah, and then multiplied by 7.
Multiplied by 7. Okay.
So Mr. Angra,
yeah.
So like
so you want us to say, using the laws of exponents, this one and this one, they're going to divide each other. So you have this one dividing this one. Okay, so what do we do next?
So shall I go 3 to the power of 4?
It's going to be 3 to the power of 4.
Multiplied by 6.
Minus.
Yeah, it's minus.
Yeah. Then this one multiplied by this one.
Yeah. 6 multiplied by.
It's 18.
Yeah, 18.
Over. It's 9. I get this one. Multiplied by 7. Okay.
And then you punch out calculator.
So you want us to use a calculator now. Okay, from here you want us to say we have 3 to the power of 4 again. And then minus 18 all over 9 multiplied by 7. Okay. And then we get our answer as what? As 1. Now, this is how you're going to get your 4 marks. After you splitted it, we'll give you 1 mark. You took out a common factor, we're going to give you another mark again. And then you splitted the denominator, we're also going to give you another mark. And then we're also going to give you a mark for the final answer. Eh?
Yes. Yes.
Okay, if you write the inverse of this one, let's start with the inverse of this one. What is the multiplicative inverse of this one?
It's going to be 4 over minus 4 over 3.
Minus 4 all over 3. Okay. So you are going to multiply this side with minus 4 all over 3 again. And then even this side, we are going to multiply with minus 4 all over 3. And then if you say this one and this one, they're going to divide each other out. And then you are left with
8 to the power of minus
2. Yeah, you have 8. What are you going to do to this 8?
I'm going to raise it to the power of minus 4 over 3.
Okay, but like 8 is not a prime number. Remember, we are dealing with exponents. If 8 is not a prime number, what do we do to something which is not a prime number?
I find the prime product.
Yeah, so we say 8 equals to shift factor. And then it gives us 2 to the power of 3, which is going to be minus 4 all over 3. Okay, what will you do then if you have something like this then?
I think the 3's are going to divide out.
The 3's are going to divide each other out. So you multiply, you'll say this one multiplied by this one. In other words, you'll have something that looks like this. You have 3 multiplied by, actually you have minus 4 all over 3. And then you're left with, it's like you're going to have x, which is going to be equaling to 2 to the power minus 4.
Yes.
And then what would you do after this one here?
I will punch it in my calculator.
Okay, so you have 2 to the power of minus 4. And then you get to which x is going to be equal to 1 all over 16. Are you happy with your answer? Are you done, or you still want to do something?
I'm done.
You are done. Now, how do you know which you have one answer or you have two answers? Remember, when we're dealing with exponents here, we need to know which we are going to have one answer or are going to have two answers. How do you know that?
I don't know.
Anyone, how do you know if you have one answer or two answers?
So Mr. Like
Agree, it's like you can have plus and minus 1 over 16, or you can have 16 1 over 16. And how do you know which you have? You have 1 all over 16, or you have plus and a minus 1 all over 16.
so ya plus and a minus 16 mistake as we like our one square to the
Which one? Agree, like you see here, you're dealing with they call them rational exponents. When you're dealing with rational exponents, for example, if I have x squared, right, and then you have 4 here. When you put a square root here and then you put a square root here, it says which x is going to be plus and a minus 2. Right? But if you have x to the power of 3, then you say, okay, you have 8 here, and then you say cube root, and then you say cube root. Because this one here is odd, it gives you one answer. So this one is going to say which x is equal to 2. But this one here, because it's an even, it says which you are going to have two answers. Okay. Now, on a fraction, how does it work then? What is it that we check on a fraction? I wanted to check that. If you still remember which on a fraction, what is it that we check? So if I have x and then I have 2 all over 5, the numerator, we check the numerator. If the numerator is even, then you have plus and a minus. If the numerator, I get this one, you have a numerator and a denominator. If the numerator is odd, then you're going to have one answer. You check the original one. Agree here you have, let's look at this thing here. What is it that we have here? We have x to the power minus 3 all over 4. Again, if you have x to the power minus 3 all over 4, you check the numerator here. What should you tell me about this numerator? Is it odd or even? It's odd. If it's odd, then how many answers do you expect here? You expect 1. Yeah. So you're going to get 1 mark for multiplying with the inverse, 1 mark for changing this one, and then 1 mark for this one. But if you're dealing with the fraction and then it had, then you needed to do something about it. You will change
So
4.
it's like, yes.
So that is
Is like 2 to the power of 2.
2 to the power of 2, all to the power of x, okay?
Yeah.
Okay, and then what will you do after that?
And then I'll write everything else as it is.
Okay, minus 2 to the power of x, which is going to be equal to 2. Okay, change this one and then put this one outside. This one goes outside and then this one comes inside.
Yes.
So that we have 2 to the power of x, open bracket, all squared again. Minus
Yes.
2 to the power of x, which is going to be equal to 2. Okay.
K method mistake. Let 2x to be k.
Let 2 to the power of x to be equal to k. Okay, if we let 2 to the power of x to be k, what are we going to have then?
K squared minus k minus 2.
K squared minus k minus 2, which is going to be 0. We can factorize, né? And then if we factorize, we have k,
Yes.
we have k minus 2 plus 1. And then it says which you can have k,
Yes.
which is going to be 2, or you can have k, which is going to be minus 1. What can I do from here, Teo?
Good mistake. Kr nagi 2 to the power x.
Yeah.
Yeah.
Okay, now that you have this, what are you going to do?
Then mistake on left hand side. Miss.
Yeah, this one.
Yeah, Mr. Come call me over, Mr. The base that's one. I got the exponent. That.
So you'll say x is 1 here. Okay, sure. And then this side,
Decide.
here there's no solution because the base is positive and then this base here is negative. So they will never be equal because one of them is positive, one of them is what? Is negative. So here we have no solution for this one. Okay, thank you for the bracket. I can write it as, look at the following. I can write it as root, again, it's 3 minus root A all over root 2 again. Because like doing nothing won't help that one. So I'm just going to try something. Let's say which you are in an examination. You should always try something. So you say you have 3, and then they say which you have minus plus y again. You come and check which one is your y. According to what they gave us here, what is our y? Our y is 4 plus a root A all over a root 2. Again. But there's a square here. What does this square mean? It means which I can repeat this thing 2 times again. So if I'm going to repeat this thing 2 times, I'm going to write it exactly the way it is. So it's minus 3 root A all over root 2 plus 4 and then it's going to be 4 plus it's 4 plus root A all over root 2. Okay, now let's use some basic mathematics. We know which if we are adding and then the bases are the same, if the denominators are the same, we can simply add the numerators. So if we have this one and this one, and then the base, the denominators are the same. Like here you have root 2, and then here you also have root 2.
Yes.
So you can just take one. So I'm simply going to take one and then say, okay, I have root 2 here all over. And then I'm simply going to add this thing exactly the way it is. So it says which I have 3 minus root A plus 4 plus root A. And then I'll do the same thing exactly, even this side here. It's fine. So I have 3 minus root A plus 4 plus root A all over root 2. Okay. Now they are like terms here. This one and this one, they are like terms. Would you agree with me?
Yes.
So the 3 is what? Is it positive or negative? This 3 here, is it positive or negative?
Positive.
So you have 3 plus 4. What is 3 plus 4?
7.
So this one is going to be 7. And then you have root A, and then we have a minus root A, and then we have a plus root A. These two here, they are like terms, but they are going to divide each other out because they are going to cancel each other out because the other one is positive, the other one is negative. And then this is going to be all over root 2. Now, whatever I got this side is going to be exactly the same thing that I got this side here. Nothing is going to change. So I'm going to have 7 all over root 2. What would you do from here, Zoom user, if it's you?
Is there?
What would you do from here then, if it was you? Let's say you managed to get up until here.
Multiply.
Yeah, you'll say 7 multiplied by 7, which gives you 49. And then you say root 2 multiplied by root 2, and then it gives you what? 2. And then into an exponent. Okay, I get you then. Sure.
And then I will do the same for the rest, which is going to be multiplied by 640 to the power 1 over 6.
To the power 1 over 6. Okay, multiplied by
810 to the power 1 over 4.
Sharp.
Times 40 to the power 1 over 2.
Times 40 to the power 1 all over 2. Okay, because you are showing here, Jane, you are proving. So I will say which you divide them as the left-hand side and the right-hand side. So you will have this one as your left-hand side. Because they are not equal. We are not sure which they are equal. So we can't equate them as yet. Okay?
And then, so... so then
Yeah.
Why are they not equal?
What is supposed to be equal?
These things.
This one is not a prime, this one is not a prime, this one is not a prime, this one is not a prime. Perhaps we can try to change them into prime products.
No, I was saying, why are they not equal to like 120?
They're equivalent to one value.
Let's leave it.
Okay, let's say 10, and then we say equals to, and then we say shift fact. And then it gives us 2 multiplied by 5 to the power of 1 all over 12.
Over 12.
Okay, if you change 640, okay, let's try 640, 640.
2 to the power of 7 times 5.
It's 2 to the power of 7 multiplied by 5, which is going to be 1 all over 6. Okay, change 810, what do you get?
2 times 3 to the power of 4 times 5.
It's 2 times 3 times 5 to the power of 4. And then this is still all over 1 all over 4.
It's 3 to the power of 4.
Oh, here I'm wrong. So here it's 3 to the power of 4.
Yes, times 5.
Times 5. 5 is to the power of 1.
Yes.
Okay. Multiplied by 40. What is 40?
2 to the power of 3 times 5.
2 to the power of 3 times 5.
Times 5.
And then this is to the power of 1 all over 2. Okay. What do you do next?
So, can I separate like the thingies?
You can raise them to the
Like the bracket.
power to the furthest power again. Agree this one, like let's write the exponents of these things that don't have exponents. The exponent is 1. If they didn't write anything, the exponent is 1. 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 Then now you can try to raise power to the furthest power by saying this one multiplied by this one. I will do the first one. It says which you have 2 to the power of 1 all over 12. And then what is going to be this one then?
That is, say,
It's 1 multiplied by 1 all over 12. Okay?
yes.
And then here you're going to have 1 multiplied by 1 all over 12, which is going to give you 5 to the power 1 all over 12. Multiplied by. Here you are going to have 7 multiplied by 1 all over 6. If you have 7 multiplied by 1 all over 6, it's going to give you 2 to the power of 7 all over 6.
Over 7.
Yeah,
7 over
here
6.
you have what? Next one, what you have?
5 to the power of 1 over 6.
5 to the power 1 all over 6. Okay, here, let's do this one. This one multiplied by this one.
2 to the power 1 over 4.
2 to the power 1 over 4 multiplied by, okay, this one multiplied by this one.
3 to the power of 1.
3 to the power of 1 multiplied by this one multiplied by this one.
5 to the power 1 over 4.
5 to the power 1 over 4. And then this one multiplied by this one.
2 to the power 3 over 2.
2 to the power of 3 all over 2. This one multiplied by this one.
5 to the power 1 over 2.
5 to the power 1 all over 2. Okay, now you will then group them then. You'll start with the ones with 2. So you have this one with 2, this one with 2, this one with 2, this one with 2 again. And then you just take 1, 2 again. You are multiplying. If you're multiplying, the bases are the same. You add the exponents. So you're going to have 2, 1 all over 12 plus this one here, it's 7 all over 6. This one here, it's
plus 1 over 4.
Yeah, and then this one here, it's
plus 3 over 2.
Plus 3 all over 2. Okay, we are done with 2 again. Let's check the next value after 2. The next value after 2 key 3. Ne? So you have 3. 3 doesn't have a friend. Okay, we're done with that one. We go to the next one. What is going to be the next one?
5.
Okay, we have 5. And it's going to be 5. Let me write it with the red color. So we have 5. And then it's 1 all over 12, okay?
Yes. Plus 1 over 6.
Plus
1 over 6
Okay, plus
plus 1 over 4
plus 1 over 4 plus
plus 1 over 2.
plus 1 over 2. All right. What then? What do you get for the 2? You add the fractions again.
Yes.
Okay, let's try to add the fractions then and see which one do we get. So we have 1/12 plus 7/6 plus 1/4 plus 2 or 3/2.
3 of 2.
And then we get 3. Ne? It says which you are going to have 2 to the power of 3 multiplied by 3 to the power of 1. Okay, do this one of 5. What do you get for this one?
For 5.
Can I type it on the calculator or you'll find that side?
No, I'm not fine.
Okay, let's try it then. So we have 1 of 6, agree here. We have 1 of 12. 1 of 12 is fine. So I'll just come and change this one here. So we have 1 of 6 sharp. And then we have 1 of 2 again. 1 of 4, it's fine again.
Yes.
And then the last one we have 1 of 2. So check it. Is it fine like this? So we have 1 of 12, 1 of 6, 1 of 4, and 1 of 2. Is it fine?
Yes.
Okay, if we say equals to, it gives us 5 to the power of 1 again. And then 2 to the power of 3 is going to give you what?
8.
Multiplied by 3 multiplied by 5 again. And then
Yes.
if you say 5 multiplied by 8, it gives you 40. And then you say 40 multiplied by 3, it gives you what? 120, which is equal to what to the right hand side, which is what we're trying to prove all along. Are you fine?
Yes.
I think Uti, we will leave it here for today, and then we'll continue